The significance of proper cooling tower water treatment, a case study. This paper presents the result of a study of the effect of cooling tower system in terms of performance and cost of maintenance. The study was conducted in a two-story shopping complex building. Observation on site was held to obtain data on full load amp and chill water temperature before and after servicing cooling tower unit. Energy of cooling tower were evaluated by analysts of FLA and CWT in percentage value. The condition of the system and component were also observed to differentiate the condition before and after treatment. The result obtained show that cooling system performance after and treatment was increased. The study. From the observation, the result present in this paper explain the potential effect of the consequences if no application of cooling tower water treatment for the central air conditioning plant. Basic operation of cooling tower process and general principles of chemical water treatment for cooling tower also explained in this study. This study also provides all the information of an important aspect containing process in cooling tower, objective of general principle of chemical treatment, problem in cooling water system, and the need for chemical treatment for cooling water circuit. The study was conducted in a double-story shopping center office building with gross floor area 18,000 meters square. From monthly energy observation report, there is an increment of energy consumption in the building for the past 3 years. Energy use intensity year 2019 increased for about 4.4% compared with EUI year 2012. The case study includes observation and data collection. Observation on cooling tower condition, taking part before and after servicing process, while data collection was focused on full load amp and condenser water temperature, which can be directly obtained from chill panel in the plant room. All the data presented in percentage value and compare it before and after the treatment, while for cooling tower condition observation, base picture before and after cooling tower being serviced. The duration of the observation was taken during 5 days before treatment and 5 days after treatment. Result. The cooling tower observation crystallized mineral deposit accumulate on heat transfer surface. The temperature of the water inside the heat exchange caused the mineral to come out of solution and from a thick layer around heat exchange tubes. The insulating effect of the mineral deposit reduced effective heat transfer. Organic and inorganic material occur on the heat transfer surface. The materials are suspended in cooling water in the form of charged particles. The charge of the metal component causes the particles to be attracted to heat exchange surface. An electrochemical reaction that gradually dissolves or wears away metal corrosion is usually the result of air-water contact. The water becomes saturated with oxygen in the cooling tower and the move into the heat exchange causing corrosion. Corrosion and fouling caused by the presence of microorganisms in the air and make up water. These microorganisms include algae, bacteria and fungus. By doing the cleaning and servicing process, it will also prevent the presence of unwanted microorganisms, which will give a potential hazard to building air circulation. Equipment failure can be catastrophic and lead to downtime injury and cause equipment replacement. Chiller operation will decrease due to presence of rust and sludge on chiller piping system. Harmful acid and occur due to this problem may cause chiller failure. Tube failure often caused by freeze damage, internal pitting, erosion, and metal deposit can result in expensive and time-consuming repair. High repair costs also include condenser retubing and replace equipment premature failure. Operation costs typically represent the largest expenditure over the useful life of a mechanical system. 50% of overall building electrical consumption was from a VAC system. Full load energy can be saved 1.5 if the evaporator temperature can be reduced by 1%. Similarly to condenser inlet water temperature, energy saving at full load is about 1.5%. For every 1 degree Fahrenheit, the entering condenser water temperature is reduced. Condenser tube needs to be cleaned if the temperature difference between the leaving condenser and the refrigerator is more than 4 degrees Fahrenheit. It is more effective to do an acid wash by circulating the acid through the tube. The untreated cooling tower water causes uncontrolled algal growth, contamination, and existence variety of microorganisms. The costly unscheduled shutdown. The building is also facing unscheduled shutdown due to equipment breakdown. System deterioration such as motor suffers a burnout, tube failure in identified as a potential costly unscheduled shutdown. Certain parts may not be available locally, bringing the parts from overseas is costly. Failed air conditioning system will cause occupant discomfort, inconvenience that may reduce of their productivity. The significant effect of the full load amp demand and entering condenser water temperature after servicing heat exchanger and cooling water cleaning was done. Full load amp is the maximum current draw that a motor of equipment can take when running at full capacity. The current usage of a cooling tower is directly related to its energy consumption because the motor that powers the fan or pump consumes electricity and generates heat while running. Therefore, the higher the FLA of the motor, the higher the energy consumption of the cooling tower. From this case study, it can be concluded that there is a compulsory plan, proactive maintenance and water treatment program in chiller plant to improve chiller reliability and increase equipment life. Well-organized schedule for routine checkup for cooling tower can reduce the frequency of unscheduled service calls and minimize the risk of the catastrophic equipment failure and the associated potential for downtime, injury, and unbudgeted costly equipment repair and replacement. All of this will overcome the high energy consumption and it will increase the effectiveness of cooling tower system as heat rejection device. Thank you.